Now let's try to solve this. Three equations are given and four variables. Okay, four variables are x, z, okay, x, y, z and x, y, z and u. Right? Now first of all write them in the form of matrices, which means Ax equal to 0. So Ax equal to 0 implies this. Right? Now using this element, I'll just say, now using this element I want to make these two elements as zeros, but that is not possible. I could do that, but then I have to multiply this with 6, this with 4, and then appropriately, and then this must be multiplied with 12 or something, and then I have to do that. Instead of that, if I could make this one as 1, it would be easier, but then to make this one as 1, there is no ones in the rows, right? But then there is a 1 in the column, but I told you that we should not perform column operations, column transformations, right? So don't do this in the exam, it requires some practice, but I'll try to do it here by doing some modifications, but you please don't try it at exam. In exam you follow the routine method. I'm just trying a different method here. Just see this. Now if I have to modify these two directly, these two columns, whatever you do, the original equations should not change, or whatever you get should always be from the original equations on applying the E transformations on the rows. Okay. Now if you just exchange these two columns, there will be a problem. The problem is the equations will change. So when you are exchanging these two columns, also see that you make the modifications in the variable matrix also, so that the resulting equations will not change. Okay, I'm not sure you're understanding this. I'll do one thing. So in order to write this matrix in a different form in such a way that 1 comes here, what should have been done is we have to rewrite these equations in such a way that, see, here the quotient 1 belongs to z. Therefore we have to do the modifications in such a way that z is not here, in place z is here, right? In such a way that this z will come here and this x quotients will go there. Got it? So when you are modifying, when you are exchanging this entire column with the first column, these two are, if you are trying to exchange, then even you should try to exchange this x and z. Now observe this. Now I have exchanged these two columns. I have exchanged these two columns. Then what should be done? You should even exchange x and z. Even this has to be done. X and z has been exchanged, right? So now if you have any doubt whether we did it right or wrong, then you could simply do one thing. Just multiply this, get the equations and see that the equations are equivalent to that. Just see this. If I multiply first row with this column, then what do we get? Z plus 2y plus 4x plus 3u. Z plus 2y plus 4x plus 3u equal to 0. It didn't change, isn't it? Now see the second one. Take the second row and multiply with this column. Then what do you get? 4z plus 3y plus 6x plus 7u. 4z plus 3y plus 6x plus 7z. So just changing the order here, changing the order of the elements in the equation requires column manipulation as well as this one also. Now since you have modified this and you are using this, carry this along the way. Otherwise by the end you might get confused and you might again write this. That is why I am carrying this all along the way till the end, because at the end we are going to get equivalent equations. There I need to know what is the order of the variables. Hope you got it. If you are not understanding it, simple thing, you take 4 here and make all of them zeros using 4 only. If you don't want to make it as 1, that requires a bit more calculations. If you understood it, fine, otherwise leave it. But then we didn't deviate from the original rule. What is that? We are not supposed to apply column transformations only on the quotient matrix. Here we are applying column transformations, but we are not just applying it on the quotient matrix. Whatever effect we get there, we are nullifying that effect by exchanging the elements in the variable matrix also. Okay, if you understood it, let's go with this. Otherwise the earlier methods, it is up to you. I hope that you understood this. So let me at least try a new method here. Okay, if you don't understand it, leave this example. Fine. Yeah. Now come to this. Using this element, now I want to make these two elements as zeros. So I'm applying the corresponding transformations. We are lucky that this element is already 0, so we are left with only one element to be made 0 in the first column. So I have to make this one as 0. So what I try to do is multiply the first row with 4 and subtract it from the second row. So R2 equal to R2 minus 4 into R1. Got it. And now using the next time is using this element, I want to make all these elements as zeros. So if you observe it, the entire row is a multiple of 5s. So we are lucky in that way. We can directly divide it with 5 and substitute there. So we can divide it there and substitute. I think you are understanding why this is possible. Why this row manipulations or row transformations doesn't change the equation. The reason is this. See, with this row, what is the equation possible? 0 into z. Check this. I am multiplying this second row with this column. 0 into z minus 5 into y minus 10 into x minus 5 into u equal to 0. Isn't it? So this term is anyway not there. Now by multiplying that entire row with minus 5 is nothing but you are multiplying every term in here with minus 5. So it is equivalent to y plus x plus u equal to 0. Therefore by multiplying y plus 2x, by multiplying this entire thing with 5, we are not changing anything in the equation. The equation will still remain valid. That is why this is a valid move, right? So now divide the entire row R2 by 5 minus 5. R2 is multiplied with minus 5 and replace there. Then I got this one. Now if you observe this, these two rows are similar. Now using this element, I wanted to make only this element as 0, but we are fortunate that even these elements are also going to be zeros, right? So now if you check it, the entire row became zeros. So whenever any row becomes 0, in fact this is in echelon form. If you are not sure whether it is in echelon form or not, ultimate aim is to find out the rank. You can stop there and see whether a 3 by 3 matrix is possible whose determinant is not equal to 0. Every 3 by 3 matrix here, whatever 3 by 3 matrix you choose, wherever, it will always contain at least one, or in this case exactly one, 0 row. So this entire row is going to be 0. Therefore the determinant of a 3 by 3 matrix, of every 3 by 3 matrix, of every 3 by 3 square submatrix inside this is 0. So rank cannot be 3. See, if you understood that it is a echelon form, it is in echelon form, then you can directly say that the rank is equal to 2 because the number of non-zero rows is 2. In case if you didn't understand it, I am just talking about it. Now you can at least see that you are able to find out a 2 by 2 square matrix, square submatrix whose determinant is not equal to 0. What is the determinant here? 1. Therefore the rank of this is 2. It cannot be less than 2 because we are able to find out a 2 by 2 square submatrix whose determinant is not equal to 0, right? But can it be 3? It cannot be 3, because if it has to be 3, then you should have a 3 by 3 square submatrix whose determinant is equal to 0. Is not equal to 0, right? But then if you take a 3 by 3 square submatrix, it is always going to contain a 0 row. So it is not possible. So rank of this one is 2. Now the rank of the quotient matrix is 2 and number of unknowns is 4. So n minus r turns out to be 2. So here n is greater than r. Now what is the condition I told you? Whenever n is greater than r, if this condition holds, then we have infinite number of solutions and we have n minus r linearly independent solutions. That is what we say. So n minus r is 2. Two linearly independent solutions exist, but totally infinite solutions exist. Linearly independent solutions, I think you know the definition of linearly independent and linearly dependent vectors. I discussed it earlier. So the number of linearly independent solutions are 2. Then how many solutions are there? Infinite. So we shall come to that point slowly. Wait. Now n minus r equal to 2. What does it mean? We have to assign n minus r, which is equal to 2 unknowns to random variables, which means random values will be assigned to 2 unknowns and the remaining unknowns will be expressed in terms of these random values, these two variables. Okay, so which two variables or which two unknowns do you want to select in order to assign the random variables is up to you. You can select any. So I'm just choosing these two, x and y. X and y, x and u are assigned c1 and c2. Now I rewrite the others, y and z, in terms of x and u. Okay, and now if you observe this one, this is nothing but the equivalent system of equations which are equivalent to the given equations. Given equations are 3 and this is the equivalent system of equations. Now how did we get this? We got this from here. And now if you understand it, carrying these 4 is important because we have changed the order. If you don't carry this, you might forget about it and write as if it is x, y, z and u, and you will get different equations which will not be equivalent to that. Now from this matrix I derived this. You can observe this: z plus 2y plus 4x plus 3u, z plus 2y plus 4x plus 3u, and you can observe this: y plus 2x plus u, y plus 2x plus u equal to 0. Got it? Now using these equations and these two values, we shall try to solve the values of x and y, and then see okay, not x and y and z, and then we shall see how many equations or how many solutions we get in total. Okay, now see this, what has happened is, after doing all this, these 3 equations, they got transformed to these 2 equations, and in these 2 equations we found out n minus r, and we are randomly assigning values to x and u. Why x and u? You can choose any variable, nothing like that. So you can take anything. I just take an x and u, you take your own, I mean you can take y and z or any combination, and after you do that, you can take these equations and you can solve the values for y and z. See, x and u, I assigned some values. Now I am trying to get y and z in terms of x and u, so that I can get in terms of those random values what the values of x and z is. So y turned out to be this one, and then z turned out to be this. See, from these 2 equations only, y equal to minus 2x minus u, minus 2x minus u, and z equal to minus 2y minus 4x minus 3u, minus 4x minus 3u minus 2 into y, and in terms of y, in place of y I substituted it. So finally what I got is, I got y and z in terms of x and u. So if you assume that, you have already assumed that x equal to c1 and u equal to c2, therefore I got y equal to this and z equal to this. So how many solutions does it have? So number of linearly independent solutions equal to 2. Why? Because n minus r equal to 2. But the total number of solutions will be equal to infinity, and this is what is called general solution. This is the general solution. There are 3 things you should remember about it. See, n minus r equal to 2. What can you say about this 2? This is the number of linearly independent solutions. And what else can you say about this number? These number of unknowns are assigned some random values, right? And these are the 2 things you can say. And then the number of solutions are infinite, and this is the general solution. These 4 points you should remember. Got it? The number of linearly independent solutions, fine, and then the number of variables which will be assigned random values, and then what is the general solution, and what is the total number of solutions. How did I get total number of solutions as infinity? If you put all zeros, definitely one of the solutions is going to be all zeros. See, in linear homogeneous equations, always 0 is a solution, which means in place of the unknowns, if you put all zeros, definitely it is a solution. One solution is definitely there, right? And apart from this, if you put the values for c1 and c2, if you substitute them here, you will get lots of solutions. For example, if you put c1 equal to 1 and c2 equal to 1, what do you get here? X equal to 1, u equal to 1, y equal to minus 3, z equal to minus 1. You substitute the values there, all of them will get satisfied. Similarly, if you put C1 equal to 2, C2 equal to 2, you get some corresponding values and you substitute there, all of them will get satisfied. Therefore, the total number of solutions equal to infinite. This is called as general solution. General solution is what we obtained here, but the total number of solutions is infinite. Number of linearly independent solutions. What is linear independence? We already discussed it. The number of linearly independent solutions is 2. Okay, fine.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.